Hello everybody. Today I will introduce you a brand new concept project. The name of the project is Quake, and it is made of a tiny smart portable device that is useful for us to stay in touch with earthquakes events that occur all day, every day, all over the world. So today we will see the product description in terms of the features that it has right now to the actual release, and we will see also the variants of the product that will be released soon. So let's dive into the specification of the product and the feature. So as said, Quake has the task to log in the internet to connect to particular data servers that are online and that we can browse normally with a browser, and they furnish us quasi real-time all the relevant data of the earthquakes that occur in a specific region every day. So just to quote some databases, it can be programmed to connect one from USGS database, EMSC database, INGV, etc. Once it has connected to the database, it downloads, based on specific filtering methods, download data and parse the data and present to the display to the user after some filtering method have been applied. So why filtering? Because we can talk about big data really, because databases are collecting lots of information all over the world or about a specific region, but you know the events are lots. And if we have to manage how to display in a way that we can recognize them, we have to introduce some filtering method. So we can say that the device has built in some filtering methods to filter the parsed data, and it can also, additionally on top of this, can apply some extra filtering based on our choices. But this will be further explained in next chapters, where we will see communication and controlling the device. So we talk this feature automatic or user-defined filtered method, like based on location, where we are, or in the time span, or in the magnitude of the events, and so on. It is necessary for the device due to the fact that we are in front of different scenarios of the earthquakes. I will explain better later, but he has to use an intelligent adaptive parameter logic. So it is different to be in front of a stable situation, for instance, where there are no particular big quakes occur in the last hours, on the last days. So we have the normal seismicity of the area, and it's very different for the device to manage this from to manage a situation where occur a big quake with a subsequent smaller one, but many in shorter time. So this feature is named intelligent adaptive parameter logic to the scenario. But I will explain you a little bit when we show the display situation. Okay. Additionally to this, talking about feature, we can say that the device can trigger automatically its way of presenting information to the user via the display, or to activate particular menus such as configuration menus or GPS activation menu and so on, just only putting it in a position. I mean, you can say there are here two identical products, the black one and the yellow one, but they are identical. What is the difference is that I put them one with the LEDs on the left side, the yellow one, while the black one has the LED on the right side. So the device knows this, can trigger in this way two different methods of presenting the information. So let's understand how. In the upper one, so in the display, will be presented the information with the logic that first he has to present us the alerted events. I mean, the events that have triggered an alarm, and we will see what is an alarm in this case, but the first alarm, the events will be presented, and they will be sorted by magnitude. So first are alarm and the maximum magnitude will be presented, then with the lower magnitudes. So this is the first way of presenting information. On the second unit, that has the LED on the left side, the information will be presented as they arrived in the time, as the server gives to us. So the first are the least accord one. I can see the last occurred event, then in the time span, the before one. So we have two different methods to present let me say the same data, but sorted in a different way. Just putting the device with a LED on the right and LED on the left. So we call this triggering of presentation mode or activation of configuration menu, just thanks to the orientation in the space of the device. We talk about proximity alerts. As you can see, for instance, on the top one, on the black one, he has alerting us that Quake is near to us. But near, why near? Because we told the device where we are. We told manually configuring it in the configuration phase, or if it has the GPS built-in, is a variant with the GPS built-in, so he can know where it is. So he can trigger the alerting just after having programmed a threshold in kilometers, so the parsing can filter them first of all. So this name proximity alerts. Additionally, we talk that there is the way of presenting information are made by a display, electronic ink display is the technology behind this black and white display. And there are three LED, colored LED. In this moment we can see two, but there are three. And through them we can quickly get into the operational state of the device or into the alarm situation. So we talk about alerting us before, and this slogan we can see is also indicated by this central LED that is red. Okay, so red means an alert raised. Okay, in terminology of the feature, the possibility to have get into touch quickly to the situation of the specific area made by the LED is called fast prompting to the user of the situation. Okay, we have the third below bottom LED that is green. This is indicating us the rate of the frequency of the earthquake that occurs in a specific area. So the device can count automatically the frequency of the earthquakes in a defined time period, and the color that LED with three different colors. In this case, it's green, so it means a stable situation. Stable, what that means? That the frequency of the earthquake is the same time by time. Should the frequency increase, it means that the situation get worse for the specific area. Okay, this LED will light orange. On the contrary, if the frequency will decrease, the LED will become blue. Okay, so it is again the fast prompting to the user of the specific area situation with the respect of the earthquakes or the specific working condition of the unit. I mean, I would know if it is successfully connected to Wi-Fi network or shall any internet problem occur. It will prompt me very quickly. Okay, we talk about the main display. The main display is made of electronic ink, is said, and has the particularity to drain very little energy to the battery, because he needs the energy just only when he writes on new characters or new pictures, but most of the time it let me say sleeps, so does not drain any energy to the battery. Additional to this, the electronics inside the main CPU can go into sleep mode as soon as he has finished to download all data from internet and parsing them and presenting them to the user. He goes to sleep. So again, this is an additional contribution to a low draining of the energy to the battery. So in few words, we can say this device is a little consumption device. So the battery, the rechargeable battery inside, can last many days without the need of recharging it. Okay, talking about the feature, we can say that it has a built-in web server via which we can use it to configure the device. I can connect to his web server that is again built-in via a terminal, via a smartphone or a computer that is located on the same local area network, on the same Wi-Fi network, for instance, and accessing to this web server, we can program some particular components that are vital to the working of the unit. For instance, for example, I can remember that the system must know the Wi-Fi characteristics, the name of the Wi-Fi, the SID name or the password to log in to the specific Wi-Fi network, or he has to know the location where he is, the home location, let me say, to calculate the distance from the event and alerting us if needed. Okay, so this is a small example where we can use the web server that is built-in to program the device the first time we power on. And finally, talking about features, we already introduced the possibility to have a GPS module that automatically locates it and does not oblige us to program the coordinates of the home location. Okay, this is briefly the list of the features that are available to the actual release of the software and hardware of the Quake project. We can say additionally that the possibility of having different databases to be connected or the possibility to have or not to have a GPS module, this creates automatically a variant of the product. So I can have like here, the black one, the variant of the black one is GPS module yes, and EMSC database connection yes. On the contrary, on the below unit, the yellow one, the GPS is not installed, and he is looking to a different database. He's looking to the INGV database. So quickly we can deploy different variants of the product, just choosing the source the type of the source, or the presence of the extra module or the GPS extra module. Okay, that's all for by the moment. We will see in future released chapters. We have additional product description that will focus on commands and controls, so the day-by-day usage of the device. We will see additionally in another chapter the initial startup, so what and how we have to do to put into service the device just when out of the box. And finally, we will see in a fourth chapter what's next regarding with this project. So the actual status of the project and what's planned in the future in terms of hardware evolution and the software evolution.